plus the reaction at y is 15g, which as a number, 15 times 9.8 is 147, which is great snooker. 91.875 times by 4/5 is 73.5. Which means the reaction at y is 73.5 newtons, subtracting 73.5 from 147. So that's found me the vertical component of the reaction at the hinge. I'm now going to find the horizontal component of the reaction at the hinge. So I'm going to be resolving horizontally. Okay. Right, looking horizontally then. I've got the reaction at x, which is acting horizontally. And then here, I'm going to have the horizontal component of t. So if this was t sine theta, then I'm going to have t cos theta here. So my reaction at x is going to be equal to t cos theta. Now, let's just pause a minute. You might be thinking, hang on a minute, why is he ignoring that force arrow there? Because surely there'd be a force going like that as well. That force is not acting on the beam, that force is acting on the wall. So this force here does not contribute to anything going on to do with the beam. Reaction in the hinge, where the beam is inside the hinge, I'm not interested in that force for this calculation. In the same way as when I did it vertically, I wasn't interested in any vertical component of this force here. So if you haven't thought about that, don't worry about it. So I have the reaction at x, which is equal to t cos theta. I know that t is 91.875. Cos theta, I haven't explicitly worked out yet, but if I go back to the triangle that I drew earlier on, cos theta, adjacent over hypotenuse, is going to equal 3/5. So 3/5 there. So if I do 3/5 of 91.875, I get the reaction x, the horizontal component, to be 55.125. However, let's look at the question. It's asking for the magnitude and direction. I don't have that yet. I have the horizontal component and I have the vertical component. So what I now need to do is I need to say, okay, the horizontal component is 55.125 and the vertical component is 73.5. So I need to draw a triangle, I need to crack out the Pythagoras here. So, horizontal component is 55.125. Vertical component is 73.5. That angle alpha is what I'm going to try and find. The magnitude is the size of the force, which is the same as this value here. And the direction is going to be the angle alpha. So hopefully you're happy that the magnitude of the force, we would do Pythagoras on this because we are working out the hypotenuse of a right angled triangle. And so if we work that out and square root that, it comes out as 91.875 newtons. And I hope that makes you as happy as it makes me. Now, the direction, I'm trying to find the angle alpha, so I'm saying that tan alpha 73/5, 73.5 I should say, over 55.125 I wonder if you believe me when I tell you that that simplifies to 4 over 3. So tan alpha is 4 over 3. So using inverse tan of 4 over 3, we get 53.13. So the direction alpha is 53.1 degrees to 3 significant figures above the horizontal. So key point for this is, if you have a hinge, then you have to consider that at the point where the hinge is happening, there is a horizontal component of reaction, there is a vertical component of reaction, and you may be asked to find the resultant of that, the magnitude and the